Hello friends, welcome to my channel ProSkill Academy. In the previous video of this playlist, we have seen what HCF is. Now if you have not seen the first video of this playlist, I have given the link of the playlist in the description. And if you are new to my channel, please subscribe to my channel so that I can bring you more such interesting videos. Now, the next big question is, after we know what HCF is, how do we actually find HCF? Well, there's not just one way. In fact, mathematicians have come up with several clever methods to figure it out. Today, we'll look at four of them. The first one being the listing factor method. This is the simplest method where we write down all the factors of the numbers of whose HCF has to be found out, and then pick the largest one, which means we have to pick the largest common factor between the numbers involved. The next method is the prime factorization method. Here we break down the numbers into their prime factors and see which prime numbers they share. We then multiply the prime numbers which they share and we get the HCF. We'll look into the detail by taking an example in the later part of the video. The third one being the Euclid's algorithm method. This is a very famous and efficient method. It's more than 2000 years old method. We'll look into the detail with an example. The last one which we'll discuss today is the division method. This is a quicker method that uses repeated division to get the HCF. Now mind you, this division method is nothing but an improved version of the Euclid's algorithm method. So when we discuss the example, you will see how we improve the Euclid's algorithm method to use the division method. Now by the end of our discussion, you will get all these methods and see how to use them. And then when we use them, you will see basically that we take same numbers but with the different methods we get the same HCF out of them. Now some of them are faster or easier depending on the numbers you were working with. Now the fun part is that after having quite a bit of experience, you get to choose which one you like the best based on your experience with these methods. Let's start with the listing factor methods. In listing factor method, what we do is that we write down all the factors of each numbers. And as I said previously, this is one of the most simplest way to find the highest common factor. There are several steps involved in listing factor methods. The first step is list all the factors of the first number, then list all the factors of the second number. And by now you would know that what factor is. A factor is basically a number that divides a given number exactly without leaving any remainder. Now in the step 3, we have to identify the common factors between the factors of the numbers of whose HCF we have to find. So this is the third step. Now once we find the common factor, we have to find the largest common factor among all of them, and that is nothing but the HCF of the given numbers. So let us see an example. Let's find the HCF of 18 and 24 using the listing factor method. So what we have to do as first step, we have to list down the factors of the first number. So factors of 18 are 1, 2, 3, 6, 9 and 18. Factors of 24 are 1, 2, 3, 4, 6, 8 and 12. And obviously 24. Now what are the common factors between them? The common factors are 1, 2, 3 and 6. And the highest factor in this chart is 6. Hence the HCF of 18 and 24 is nothing but 6. So this is how we find the HCF of a number using the listing factor method. In our next method, we will discuss about prime factorization method. So what we will do in prime factorization method is break each number into its prime factors and then find the common prime factors and multiply them to get the HCF. So the first step being write the prime factors of the first number and then we write down the prime factors of the second numbers. And then find the prime factors which are common to both of them and then multiply the common prime factors, and that would give the HCF of the given numbers. And this we can extend to multiple numbers. It doesn't mean that we have to use this method only for numbers where two numbers are involved. So let us take an example. We take the same numbers 18 and 24 again. Now to find out the prime factor, what we will do is that we'll take the given number, say for example 18, we start dividing with the least prime number. So the least prime number is 2. Now if I divide 18 by 2, we get 9. Now 9 is no more divisible by 2, hence we take the next prime number, that is 3. Now if I divide 9 by 3, I will get 3. Hence 18 can be written as 2 to the power 1 because I have only one instance of 2, and then 3 squared because I have two instances of 3. Now similarly I find out the prime factors of 24. So the least prime number is 2, which will divide exactly 24, and if I divide 24 I will get 12. Then I can again divide 12 by 2, will give me 6. Then I can again divide 6 by 2, which will give me 3. Hence 24 can be written as 2 cubed into 3. Now what is common between them? Which prime factors are common between them? 2 to the power 1, because this is the common part, because in 18 it is 2 to the power into 3 square, and for 3 we have again 3 to the power 1 as the common part. So hence the HCF would become 6. So if you have observed now, the HCF of the two numbers which we got with listing factor method and prime factorization method is coming out to be the same. Now let's discuss about the Euclid's algorithm method. The HCF of the two numbers also divides their difference. This forms the basis of the Euclid's algorithm method. This means that we repeatedly replace the larger number with the difference of the two numbers until they become equal. And when they become equal, that number is nothing but the HCF. So there are several steps involved in it. So the first step being, we have to take the larger number and the smaller number, and then subtract the smaller number from the larger number and replace the larger number with the result. Now mind you, the result might be smaller than the other number involved. Hence you have to always take care that you are subtracting the smaller number from the larger number. Now repeat until both the numbers are equal. That common value is HCF. So let us see an example. Find the HCF of 56 and 72. Here 56 is smaller number and 72 is larger number, and we subtract the smaller number from the larger number. So the first step being 72 minus 56, which would give me basically 16. Now I have to replace the larger number, that is 72 will get replaced by the difference. So 72 get replaced by 16, and then I have to again subtract the smaller number. So between 56 and 70, between 56 and 62, 56 and 16, 16 is the smaller number. That means I have to subtract the smaller number, that is 56 minus 16 equals to 40. Now again I will replace the larger number by the result, that is 56 will be replaced by 40, and in between 40 and 16, 16 is the smaller number. Hence what I will do, I will subtract smaller number, that is 16, from 40, and it will give me basically 24 as the result. Now 24 gets replaced with 40, and between 24 and 16, 16 is the smaller number. So what I will do is that 24 minus 16, which will give me 8. Now 24 will get replaced by 8 because 24 was the larger number in the previous step. So the next step would be 16 minus 8. This would give me the result as 8. Now the larger number here is 16 and 16 gets replaced by 8, and then I have to subtract it again from 8 because both are equal and it gives me the result. And this is the most important step because both the numbers are equal here. That means that equal number which gives me the result as 0 is nothing but my HCF of the two numbers. Hence the HCF of 56 and 72 is nothing but 8. Let's move to the next method and you will see the magic here basically, and where we will take the same numbers and we will get the same result. So in the division method, basically we divide the larger number by the smaller number. We then take the remainder and divide the previous divisor by this remainder. Repeat the process until the remainder is 0, and the last divisor which gives me the remainder as 0 is nothing but the HCF. So let's see an example again. Here we are taking the same numbers 56 and 72. So what we have to do is divide the larger number by the smaller number. Here 72 is the larger number and 56 is the smaller number. Now if I divide 72 by 56, I get the quotient as 1 and remainder as 16. The next step what we have to do is that basically we have to now take 56 and 16. So I am replacing 72 with the remainder. So this is something which is quite related to the Euclid's algorithm method. Here the difference is basically getting replaced by the remainder, and ultimately this means the same thing, but this is little bit faster. Now the next step would be I would divide the larger number between 16 and 56. That is, I will divide 56 by 16. This is 56 by 16, and I will get the result as quotient is 3 and remainder is 8. Now in between 16 and 8, 16 is larger, and I will divide 16 by 8, where I will get the remainder as 0 and quotient as 2. Now if you notice here, when I am dividing it by 8, the remainder becomes 0. As soon as the remainder becomes 0, this number which we use to divide the larger number is nothing but the HCF. And in the Euclid's method also, we have seen that the HCF of 56 and 72 is 8. Hence this proves that whatever method we choose, we will get the same result. Some are faster, some are slower, and some are efficient based on the numbers what we are using. So now this brings to almost end of this video, but before we end, what we have seen is that 4 different methods to find HCF. First is the listing factor method, simple but time consuming for bigger numbers. Then is the prime factorization method, where it is useful and systematic, especially for smaller numbers. Then we have seen Euclid's algorithm method. This is based on subtraction and quite easy to understand. And then finally we have seen division method, and this is the most fastest and efficient way. Now you decide after practicing which one you feel more easy for you, and the same one you can use for your practice and future use in your competitive exams and other exams. Now all these methods ultimately will give you the same result, but division method, as I said, is generally preferred for larger numbers. So that's it for this video. If you have any question, please feel free to comment in the comment box and I will be ready to answer all your doubts. Now remember, the highest common factor is a very important concept in mathematics, and knowing multiple methods would help you solve problems in different ways. That's all for today's session. I hope this made the idea of HCF very clear to you.